let's see, I think last time we met, we were working on worksheet 4. That was the last thing that we had talked about in class. I think that's set to be due this week. Do you guys have questions from worksheet 4? I guess anything prior even is okay too. Okay, well, why don't you take a look at it? If you have, it sounds like maybe not a lot of us have taken and spent much time with that yet, because typically these are rather challenging problems. So let's take a minute and look through this, right? So to kind of remind us, you want to do a couple of these, right? If you haven't done anything, it's been over a week now since we've done this, and this is not typically not trivial, these kinds of problems. So let's just kind of remind ourselves what to do here. What do you think? Do number 1? All right. So it says that we want to construct a sinusoid. So what does it mean by sinusoid? So it wants a sinusoid as either one of these sine or cosine equations. So when it says we want to construct a sinusoid, it's talking about an equation in one of these two forms. Does it matter which one you write? No, either can be correct. It's a matter of preference and maybe which one of them is going to be easier, because sometimes one is easier than the other. Everybody's okay there? So what this problem really boils down to is we have to figure out the values for like A, C, H, and K in order to write the sinusoid. Okay? So let's go and look at the information that's given. It says an amplitude of 5. Remember, the amplitude is related to which of these coefficients, A, C, H, and K? This would be something you'd want to remember. The amplitude is the absolute value of A. So in this case, that would mean A should be 5 or negative 5. Everybody's cool there? It tells us the period needs to be 6 pi. What is the period related to? A, C, H, or K? Again, this is one you'd want to remember. The period for sine and cosine is 2 pi absolute value C. So 6 should equal 2 pi absolute value C. I divide by 2 pi. So that tells me that c is 3 pi or 3 over pi or negative 3 over pi. But remember that we always want to pick our c to be positive. You can get right a correct answer either way, but it's typically going to be easier to make the c positive. That's what I would encourage you to do in all circumstances. Everybody's okay there? So we have C. We have almost all of A, right? We just need to decide whether it needs to be positive or negative. But we don't have H, we don't have K, and we haven't decided whether we should be writing a sine or a cosine function. We have only one thing left, is that our sinusoid has to pass through this point. Now notice, it just says pass through, right? Just says pass through. Does it tell us what kind of a point negative 2,8 needs to be? No, it doesn't specify that negative 2,8 has to be a minimum. Doesn't say it has to be a maximum or a midpoint. It doesn't say at all. All it says is it needs to pass through that point. So we have a choice then. We can choose to have negative 2,8 fall wherever we want on our function. It could be a midpoint, it could be a maximum, it could be a minimum. It doesn't matter. We get to choose. Everybody okay with that? What's going to make the easiest choice? Is choosing that to be a midline point that's followed by a maximum. The reason I want to do that is because then I'll pick sine as the kind of function I want to use. And then I'll go to my parent function for sine. And I'll pick one of the midline points to use. This would be the midline point I would choose. Zeros in the coordinates make it easy to use. So if I'm given the option of a point to pick, I want to try to pick one that uses the zeros or has some zeros in it. And notice that following this midline point is a maximum. I can tell because it's got the biggest y coordinate of the 5. Everybody's okay with that? So from the parent function, we're going to use the point 0, 0, which is a midline point followed by a maximum. And we're going to transform that point 0, 0 to the point negative 2,8 in our resultant function, where negative 2,8 is also a midline point followed by a maximum. Notice that we've chosen now to use sine because we're taking our parent function and transforming it to the same kind of point. That tells us that our value for A needs to be positive. Everybody's okay there? Since the x-coordinate of our parent function is a 0, the x-coordinate from our resultant function needs to be our h. Similarly, since the y-coordinate of our parent function is 0, the y-coordinate from our resultant function has to be our k. And that's all we need to get our final answer. So one possible answer could be that. Everybody, we okay with what we did here? Is that okay? This is the easiest version of this kind of a problem. What makes it easy is because we're not specifying what kind of point -2/8 needs to be. So you have the ability to choose it to be a midline point maximum, which makes everything afterwards really easy, because it just all naturally kind of falls out for you, that the coordinates are just the h and k, and the sign for a is just going to be positive as long as we're using cosine. Is that okay? What would make this problem more difficult? What's the next thing we could do to make this more difficult? Well, we could specify what that point needs to be. Let's see how this problem changes when we do that. So the amplitude of 3 does the same thing, just tells us that a needs to be either 3 or -3. A period of 5 tells me that 2 pi absolute value of c needs to be 5. So when we divide both sides by 2 pi, c needs to be 5 over 2 pi, or -5 over 2 pi. But as we mentioned earlier, we're always just going to pick c to be the positive option. Now, here in this problem, we're told that that point 5, -6 is a minimum. Which function should I choose to use here then, sine or cosine? If I'm told that 5, -6 is a minimum, which one should I choose? Which one is going to make the problem easier to do? Should I choose sine or should I choose cosine? Should choose cosine. The rule for making that decision is if the point is an extreme point, that is, it's a maximum or minimum, we should use cosine. If it's a midline point, you should use sine. If you have one of each, doesn't matter. You could pick either one. It'll be fine. Is everybody okay there? Now, from cosine, if I go and I look at my parent function, for cosine, I need to pick one of the extreme points, either a max or a min. Of these, the one that I want to choose is 0, 1, because it has a 0 in the coordinate. That'll make our life a little bit easier. And I'll note that this is a maximum because if I look at the y-coordinate, 1 is the largest y-coordinate that occurs in that set of points. Everybody's okay there? Oops. So just like before, for my parent function, I'm going to pick the point 0, 1, which was a maximum. And we're going to transform that point into the point 5, -6, which needs to be a minimum. Since our parent function is going from max to min, what does that tell me about the value for a? Needs to be negative because we're switching types. since the x-coordinate of our parent function is 0, the x-coordinate of our resultant function is our value for h. But here's the catch now. But look at the y-coordinate. The y-coordinate of our parent function is not 0. So we're going to have to actually do a little bit of algebra here. So recall that a times the y-coordinate from the parent function plus k is equal to the y-coordinate from the resultant function. That's just using that transformation map that we do when we're graphing, right? Oops. Come back, everyone. Right? You remember this guy? What I've written down here is just the same thing. So when I plug in my values for a, the y-coordinate from the parent function, and then the y-coordinate of the resultant function, that leaves me with an equation I can solve for k. If I add 3 to both sides, I get that k is -3. So that's all I need. What do you guys think? Is that okay? And then what's the third variation we can do to this to make it even more tricky? Is to just give you 2 specified points and not give you anything else. So if I look at one, say like number 5, notice here that all we're giving you is a maximum and a minimum. So if I were to kind of sketch what we have, I know about like this part of my graph, right? Everybody agree with that? Now, if I think about this, the midline is going to go right through like the middle of that part, right? So the midline needs to be halfway in between 10 and -18. What's halfway in between 10 and -18? About -4. Right? That's going to be 14 units up from -18. And if I go 14 units up from that, I'd be at 10. Everybody agree with that? Coincidentally, that tells me that the amplitude is 14. Note that this is the same thing as using a formula. So some of us are visual people. I'm a visual person. Some of us are formula people. So if you prefer to calculate the amplitude and the K using a formula, you can use those two formulas. If you prefer to just kind of look at the picture and make sure that things make sense and kind of do some counting, you can just look at the picture and do some counting. All right. So from the midline at -4, I know the midline is the same as the K. And I know the amplitude is the same as the absolute value of A. So I know that K is -4, and then the A is either 14 or -14. Is everybody okay with that? You like how I'm color coding this so that the work for the things match up? I'm trying hard to be super organized for you. Okay. The next thing I'm going to worry about is the period. Now notice that what I've drawn here isn't a full period, right? My period would end once we get back to another maximum. You guys agree with that? The solid red part that we've drawn, how much of a period does that look like? What percent of a period? So if I continue doing all the dash, that's a full period, right? How much is the solid part? Half, right? Looks like 50%. You guys agree? Do you see it? That's correct. And that half of a period is going to go from -2 to +14. How far is it from -2 to +14? That's 16 units, right? Or you can just do the absolute value of the difference. Is everybody okay there? Now remember, the period is the same thing as 2 pi, absolute value C. One half times 2 is just 1. So if I divide both sides by by pi, I get that C is either +16 over pi or -16 over pi. But remember, we always pick the C to be positive. Everybody's doing okay? We have a few things left to do. So we still need H. We still need to decide whether the A should be positive or negative. And we still need to pick whether we're going to do a sine or a cosine. First thing we should do is pick whether we're doing sine or cosine. Which one should I use in this problem, sine or cosine? Cosine. Why? Because we're given maxes and mins. So when we use cosine, we're going to use the point 0,1, which is a maximum. And then we're going to pair that with, does it matter which point I use? No, they're both extreme points. Will we get a different answer depending on which one we use? Yes, but they're equivalent. They're both correct answers, but they're going to look different. So for the sake of argument, let's just pick the first one, which was a maximum. Since I'm taking a maximum and transforming it to a maximum, what does that tell me about the sign for A? It needs to be positive. And because the x-coordinate of my parent function is 0, the x-coordinate for my transformed function is going to be h. And now I have everything that I need. Is this jogging your memories? We did this last time. So look at this. If you haven't started the assignment yet, you're halfway done now, right? That's pretty nice. Thanks, Mr. Kulik. You're welcome. All right. Today, we're going to do section 3.2. This is all about the tangent function. So just like before, we're going to use the unit circle to create the graph for our tangent function. So remember, back when we were using the unit circle, tangent of an angle was equal to y over r, right? So what I'm going to do is I'm going to plot the point where x is my angle measure, and the y-coordinate for my function is going to be the value for sine divided by the value of cosine, or y over r. So my first point is at 0 radians, and tangent of 0 should give me 0 over 1, which is still just 0. The next point is pi over 6, and then I have 1/2 divided by the square root of 3 over 2. The decimal approximation for that is 0.577. Then we have pi over 4. And then we have root 2 over 2 divided by root 2 over 2. Well, that's just 1. Then we have pi over 3. And we have root 3 over 2 divided by 1/2, which is 1.73 is the decimal approximation of that. And then we have pi over 2. And then I'd have 1 divided by 0. Oh, what's 1 divided by 0? That's undefined. So what's that going to mean on our graph? How do I graph something that's undefined? That's going to be a discontinuity. Okay? So remember we talked about discontinuities way back in chapter 1. There are 3 types. Anybody have a guess as to what type this one will be? This one will be an infinite discontinuity, also known as a vertical asymptote. So it's the way I'm going to represent that in my picture is I'm going to draw a vertical line, And well, let's do this as long as I'm at it. Make a trig axis there with pi's on my x-axis and get rid of the grid lines. Okay. And then let's continue on. So I have 2 pi comma 3, and then negative 1.73. And then I have 3 pi comma 4 and negative 1. And then I have 5 pi negative over 6 comma negative 0.577. And I have pi comma 0. And I have 7 pi over 6 comma 0.577. And then I have 5 pi over 4 comma 1. And then I have 4 pi over 3 comma 1.73. And then I'm going to have 3 pi over 2 comma negative 1 over 0. Oh no, another asymptote. Let's just make that red also so it matches. I'll make that, give that a dashed line. And then I'll keep on going. So 5 pi over 3 comma negative 1.73. And then 7 pi over 4 negative 1. And then 11 pi over 6 negative 0.577. And then 2 pi comma 0. And then we could just keep going around the unit circle again, but let's not, right? Okay. So if we look at this, it's our graph for tangent. What do you notice about the difference between this and the sine and cosine graphs? Well, right away, this isn't a wave, right? This is not a sinusoid, although it is periodic. It's repeating over and over and over again. But as these asymptotes, it's not continuous. It doesn't have like maxes and mins to it. So let's talk about this tangent function. What's the domain for this going to be? Remember, the domain for sine and cosine was all real numbers. But certainly that's not going to be the domain for tangent, because we have these asymptotes all over the place, right? Everybody notice that? We got these asymptotes all over the place. Oh no! So how are we going to describe that domain? Well, we can't use an interval notation. So we're going to say the domain is all real numbers except for where these asymptotes are. Everybody's okay with that? So how many asymptotes do we have? Infinitely many, right? Because this graph just keeps repeating forever. So we're going to keep getting asymptotes forever. Everybody okay with that idea? So the way we're going to do that is we're going to describe the asymptotes with a location of one of the asymptotes. I'm going to use that one that happens at pi over 2. And then I know that because this is periodic, the distance between the asymptotes is going to be the same. That distance between those asymptotes is pi. And I'm just going to slap a k onto that, where I'm going to say that the k is any integer value. So what are we really saying when we say pi over 2 plus pi k there? It's really the same thing as saying, okay, at pi over 2, and then every angle measure that's going to be coterminal to pi over 2. But wait a second, Mr. Kulik, I thought coterminals you're adding 2 pi, not 1 pi, right? Everybody agree with that? Well, what do you notice about the length of the period for tangent? Right? That this is the length of the shortest non-repeating segment. What do you notice about the period here? It's just pi, not 2 pi. Uh-oh! Notice then that the frequency would necessarily be 1 over pi, since the frequency is just 1 over the period. I want to point out to you, I want to repeat this again, the period for tangent is pi, not 2 pi. I would say a half or maybe more of us are going to forget that I'm going to be able to trick you with that fact at some point on this test. This is me announcing in advance that I'm going to try to trick you with that. So that's just for you to be aware that Mr. Kulik's going to try to trick you, and because he's counting on you forgetting that the period for tangent is pi and not 2 pi. So I'm announcing to you to try to see if you can remember to not get fooled. Okay. What's the range going to be then? Is there a global maximum or a global minimum for this function? No, there's not. Why not? Well, I have an arrow that points down forever and an arrow that's pointing up forever, right? That's telling me that there is no global minimum or a global maximum. So the range is just going to be all real numbers. Oh, that's a relief at least. That's easy. Everybody's okay there? Notice that we have a midline still for the tangent function, right? That's our midline. At y equals 0. What's the definition for the amplitude, though? The amplitude was the distance from an extreme point back to the midline, right? Do we have any extreme points in a tangent function? No, we don't, right? Because there is no global maximum or global minimum. Oh, no. Okay, so there's no amplitude. But Mr. Kulik, what are we going to do when we are trying to write the equation from a graph of tangent? How are we going to get the value for A? Well, if you look at this, if I look at the interval from a midpoint to the asymptote, and you look at halfway on that interval, and I look at the point that corresponds to that, the distance from that point back to the midline is the absolute value for A. So if I look at halfway in between the asymptote and the midpoint, the distance from that point back to the midline is the absolute value of A. So it acts kind of like our amplitude did. Is that okay? That's the easiest visual that we'll have to find the absolute value for A. Okay. What if we want to talk about the tangent function in general, though? Right? What if we talk about its resultant function? Is a transformation going to change the domain for our tangent function? Yeah. Right? Because the transformation can change two things about our domain. It can change the location of our asymptotes, and it can change the distance between the asymptotes. So what coefficient is going to change the location of the asymptotes? That is our value for h. If we translate the graph horizontally, that'll move the asymptote as well to a new location. And then if we horizontally stretch or shrink our graph, that'll change the distance between the asymptotes. Right? And remember, the distance between the asymptotes was the same as the period. So the period just should be pi c. The range won't change, though. It was all real numbers before. If I stretch or shrink or shift, that's not going to change the range at all. The midline, just like before, if we shift that up or down, we change the location of the midline. And again, we still have no amplitude. So that's kind of our stuff about the tangent function. Let's do a couple of examples here. So we'll do two different kinds of examples. We're going to write the graph for a tangent function. And then we'll write the equation from the graph. Okay, so maybe we do this. So let's say we want to graph y equals -3 times tangent of x over 2 plus 1. My first order of business is going to be to rewrite this in the general form so that I can find my values for A, C, H, and K. So when I do that, I get A is -3, C is 2, H is 0, and K is 1. Everybody okay with that? Again, super important skill that you're able to pull those values for A, C, H, and K from an equation. This is a fundamental skill for like 50% of the problems we do in this chapter. If you cannot consistently and effectively do that, it's going to be difficult to get things correct over and over and over again. So if you are still having problems with that, you should come see me and we can talk some more about it. But this is something we've spent quite a bit of time on in previous sections doing. Okay, so next thing I'm going to do is I'm going to write my transformation map. The nice thing is that it's the exact same transformation map we've used before. So I'm just going to fill in my values for C and H and A and K. And then I'll go to my reference point sheet, go and find tangent. So I'm going to use just those in white. So I'm noticing here that I have -pi/2 and then und. What the heck does und mean? It's just shorthand for undefined. What does undefined look like when I graph it? That's going to be the vertical asymptote. Oh, okay. All right, let's just plug things through. 2 times -pi/2 is -pi. And then -3 times undefined plus 1. Still undefined, right? Doesn't matter what you do to undefined. It's just staying undefined. Multiply it, add it, subtract it, whatever. Undefined is still undefined. Everybody's cool? Okay. 2 times -pi/4 becomes -pi/2. And then -1 times -3 plus 1 is 4. 2 times 0 is 0. -3 times 0 plus 1 is 1. 2 times pi/4 is pi/2. -3 times 1 plus 1 is -2. And then pi/2 times 2 is pi. And anything you do to undefined still stays undefined. So it looks like things are going by half a pi's. So -1.5, -1, -1/2. There's 0. Okay. So what I usually like to do is to draw in the asymptotes first. So at -pi, I'll draw in one of my asymptotes. And at +pi, I'll draw in the other asymptote. And then at -pi/2, 4, 0, 1, and +pi/2, -2. So when I draw this, it's going to look like that. It's kind of lumpy. My apologies. Everybody's okay? And now I'm just going to extend to fill the space. What do you guys think? It's a piece of cake, right? Exactly the same process as we did for graphing sine and cosine. The only difference is, we have to draw in these asymptotes and the shape is different than the other. But it's like, whatever, right? Like, no big deal. But otherwise, it's the exact same process, right? The only change happens when we go to actually draw the graph. And like, whoop-de-doo-doo. Yes, sir. Absolutely. Do you feel okay doing this? Shouldn't be bad, right? Let's go the other way. Let's go from graph to equation now. This will be the last skill that we worry about in this section. All right. So the approach I'm going to take here is going to be very similar to the same approach that I took when we did this for sine and cosine functions. First thing I'm going to do is I'm going to look for the midline. The midline appears to be coming right through here. And I remember that that just gives me my value for k. Everybody's good with that? I remember that the period, well, that's going to just be the distance from asymptote to asymptote. So if I go from negative pi over 4 to positive pi over 4, how far did I go? Well, that's 1/4. That's 2/4. So I went 2/4 pi, or just pi over 2. Now don't let me trick you guys. The period for tangent is pi times c. So hopefully it's easy to see then that the c is going to be 1/2 or negative 1/2. But again, we always pick the c to be positive. Everybody's good there? Okay. To find the absolute value of a, remember what we did is we're going to look halfway in between the midpoint and the asymptote. And we're going to look for the distance from that point back to the midline. That's going to be our absolute value of a. How far was that? Just 1 unit, right? So a is going to be either 1 or negative 1. Okay. The last thing I need to do then is I need to go to my parent function and pick a point to use. If I go to my parent function for tangent, the point that I would be using is 0, 0. Notice that's a midline point. And prior to that midline point, the graph points down because it's the y-coordinate's negative. And after that midline point, the graph points up. Notice that the y-coordinate on the next point is positive. Now from the resultant function, I'm going to go ahead and choose one of the midline points. It doesn't matter which one. Although, come on, guys, why would you pick anything other than the one that's labeled for you? Right? Like, durr. And if I look at that midline point, 0, -1, I notice that the left end is pointing down and the right end is pointing up. So it's the exact same kind of midline point as my parent function. That'll tell me that the value for a needs to be positive. And then since the x-coordinate of the parent function is 0, the x-coordinate from the resultant function is going to be my h. And I have everything that I need. Oh, yeah. Oh, can somebody grab the door for Matt? I locked it on accident, I guess. Thanks, Elise. Well, she doesn't have the key to unlock it. It's okay. I'll get up and do it in a minute. Let's do that one more time and call it good for today. What do you say, Elise? Sure. You might want to kick the doorstop in for yourself before you go so we can avoid the same situation, although I guess Matt owes you one now, so if you wanted to be a pain, you could cash that in. Sounds like she's not going to be, though. I heard the doorstop go in. Okay. Same question here. Well, I mean, it's not a different problem, but the same question. We're trying to write the equation for this. Does anything really change when I do this in my process? No, man. Doesn't matter. Whatever it looks like doesn't change the way I'm going to approach this. So I'm going to start the same way, looking for that midline. So I know that the k is 2. We're going to look for that period going from -pi to 0 is just pi. So the period here should be c equals 1 or -1. But we all at this point should be comfortable. Just the c we always choose to be positive. Okay. To find that absolute value of a, I'm going to look halfway in between my midpoint and my asymptote and look at the distance from that point to my midline. So going from 5 to 3, how far did we travel? I'm sorry, 5 to 2. We travel 3 units. So far, so good? No big deal, right? All we're doing is like basically counting. Here's the trickiest part. From our function for tangent, we go to our parent function. We're always going to use that 0.00, which is a pointing down midline point pointing up. On our resultant function, we're going to pick some other midline point. I can pick any one I want, but come on, like I'm going to use the one that's labeled for me. I notice here, though, that this midline point, we have a pointing up, midline point, and then pointing down. And notice those are opposite kinds of midline points. That tells me that the value for A should be negative. And the last thing I need to do is find the H. But as long as that x-coordinate for the parent function is 0, the x-coordinate for the resultant function will just be my H. So I am dunzos. What do you think? It's not bad, right? It's all right. So next time we can do 15 to 26. And we should be able to do worksheet 7, numbers 1 and 3. So this would be for this weekend. So what's that? The 24th, I think? Is it the 23rd? The days of the week are hard, guys. 23rd. So that's it for section 3-2. What haven't we done yet this chapter? What do we usually do every chapter that we haven't done yet? Homework quiz. What might be a good idea to be ready for next class? A homework quiz. If I were you, I would want to be familiar with the things we did in 3-1. I wouldn't worry about any of this tangent stuff for the homework quiz. You should be able to graph a sine or cosine function. And you should be able to write the equation from a sine or cosine function, either given a picture of the graph or a description. Okay? So we'll do that next time. And I'll have a delta math assignment for you guys to work on after that. And then that's all for chapter 3. This was the last topic we're covering in chapter 3. So the following class, what would that be? Monday next week? Review day. And then the test on Wednesday. That sound all right? So if you wanted to start working on your half sheet of notes or whatever, you're welcome to do that. You do not have to wait to the review day to start working on that. Sure.